Welcome all of you to this video of Maths Made Easy. Now in this video we are going to do special functions. Okay, the special types of functions. Now in my last video we had talked about functions. In this video I am going to take up all the special types of functions that we have. Okay, so let us start. The first type of special function is a constant function. Constant function. Now what is a constant function? It simply means that there can be a constant k. Okay, if there is a constant k, constant function is, suppose this is here is set a and here is set b, and I have a real valued function from a to b. Then here is x and fx is always equal to k. Now fx this is a constant value, this is not a variable. Now here I can have x1, fx1, I can have x2, fx2 is also equal to k, fx3, okay, fx3 is also equal to k, okay. So fx1 is equal to k, fx2 is equal to k, fx3 also equal to k. Means for all the values here, for the entire domain, whatever is there in the domain, the image of that is always one constant value. That makes a constant function. Let's see the next type of function. Identity function. Identity function. Now what is identity function? Identity function is such a function where each member of the domain, okay, each member of the domain x1, x2, x3, x4, each of these members are mapped onto itself. Now what do you understand by that? They are mapped onto itself means their image is also same, means here is also x1, means f x1 is equal to x1 again, okay, f x2 is equal to again x2. Now this is an identity function. So we say when each of the members of the domain are mapped onto itself, okay, so y1 is equal to x1 and y2 is equal to x2. So that is called an identity function. So let's see the next type of function. Very important, modulus function. Okay, now what is a modulus function? Fx is equal to x bar, note this sign, when, okay, x, this is equal to x, when x is greater than equal to 0, means x is either positive or 0, and x minus x when x is negative. Now let us understand this. This is a modulus function. Now you already know this is modulus, or we call it absolute value. So here if I put a 3, supposing I am finding f3, okay. So here I'll put a 3, positive 3, okay, plus 3. So plus 3 and it comes out as a 3. So if x is greater than or equal to 0, that is the case here, okay, I put a greater than or equal to 0 value, then it is equal to 3. Okay, when x is greater than or equal to 0. Now let me take minus 3, which is minus 3 and it comes out 3 again. Now this can confuse some people. Some people get very confused with this. Okay, so let me explain this. This is 3. What is this 3? Okay, it has lost its sign because of this minus, because of this modulus. Now this is 3. Now here they are saying when x is less than 0, then the value of x is minus x. Now let me tell you, x was already minus 3. Yes, this was my x. What came out of the modulus sign is a plus 3, means minus of this. So what comes out of the modulus is minus of minus 3, means minus of whatever value you had put it. So we get this minus x, which is x less than 0. Okay, so that is a modulus function. If you put a 0 here, we'll get a 0. If you put a mod 0 is a 0. So is equal to whatever in that case it will follow this rule. Whatever the, if x is equal to 0, then our result will also be 0. So this was modulus function. Let's see the next type of function. The next type of function is a very new thing for you all. Okay, this is the greatest integer function. What is greatest integer function? Let's see. Okay, now the sign. So for greatest integer function, we can write, like this. X is written like this. Okay, so it is written in the, you can say, the third bracket. It is not the same as modulus. What does it mean? Now if I put a 4 here, which is the greatest integer less than or equal to 4, we have to find the greatest integer which is just less than 4, or it can be equal to 4 also. Okay, so what is it then? If it is just less than 4 or equal to 4, here 4 itself is an integer, so it is 4. But now see, if I write 1.3, okay, this is a decimal number. Which is the greatest integer which is greater, which is less than 1.3 or equal to 1.3? Now 1.3 is not an integer. Now we'll have to look for the integer which is just less than 1.3. Okay, so the integer which is just less than 1.3 is 1. Okay, let me take one negative number now. Let's see. We'll take one negative number. Now see. Okay, this is not an integer clearly, and the greatest integer which is just less than this. Let me draw the number line. 0. Here is 1. 1.3 will be here. Okay, and here I have 2. So the integer which is just less than, this is 1.3. The integer which is just less than 1.3 is a 2 this time and not a 1. Okay, so when you are talking about negative here, be a little careful. Okay, be a little careful, because greater values, okay, the just less than values will be coming to the left of the number line. Okay, so you have to be little careful in these negatives. So this is the meaning of greatest integer function. If it is a whole number, well and good, give it the same number because it's an integer. But if you have decimals, be little careful, especially if you have negative numbers. Okay, so you have to think like this and then work it. Okay, the next type of function, special type of function, is the signum function. Now in this, very interesting, there is a new word for you all. Okay, so don't miss it. So fx is mod x by x, or this is how the function is defined, or fx is equal to 0. Okay, this one, for x not equal to 0, for x is equal to 0, we use this. Okay, so for if x is equal to 0, then fx is also equal to 0, no problem, we are using this. Okay, but then if fx is not equal to 0, some other value, then let's talk about this. If x is greater than 0, x greater than 0, now what happens? Means x is positive. Greater than equal to 0 can't happen. Here we have 0. Okay, so only greater than 0. Now what happens? We take, let's say, mod 3 by 3. What do we get? We take 3 by 3, which is equal to 1. So fx is equal to 1. Yes. Now if fx, x is, now if x is less than 0, means x is a negative value now. Now see what happens. Then fx is equal to, here let me take minus 3. Okay, let me take minus 3 here, f minus 3, and by minus 3, what happens? This comes out as a 3, this is a minus 3, I get a minus 1. Okay, so if x is less than 0, then fx is equal to minus 1. Okay, so fx becomes equal to minus 1. Let me draw the graph for this. This is the x and y axis, and here we have the origin. This is 1 in the y axis. This 1 in the y axis means 0 1. Okay, means x is 0, okay, and y is 1. So x is 0, y is 1. Now let me draw this line. Now I'll draw this line which is parallel to the x-axis. Okay. So for any point where, here x will have one value, here x, all positive values, you see x will have all positive values here. So maybe this is, now this is x1, y1, x is 2, y is still 1, x is 3, y is still 1, x is 4, y is still 1. That is why we get a line which is parallel to the x-axis. Okay. Now we'll draw another one which is like this. This is 0 and minus 1. 0 and minus 1. Here we'll have x is minus 1. Okay. Y is minus 1. Why? For all negative values of x. Look here, for all negative values of x, y is, fx is equal to y is minus 1. Okay, for all negative values you see y is now minus 1. That is why this graph. So this line has to be parallel to this, and this line has to be parallel to the x-axis. So this is the meaning of this graph. If you remember this graph, you can actually remember the signum function. Now let me talk about odd and even functions. Odd and even functions. Okay, what are odd and even functions? Let's see. For odd functions, if f minus x is equal to minus fx, okay, I'll give an example, then you will understand. If fx is equal to sin x, okay, that is the function. Now f minus x is sin minus x, okay, which is equal to minus sin x, which is equal to minus fx. So f minus x is equal to minus fx. Then this becomes an odd function. Let me talk about even functions now. For even functions, if we have fx is equal to cos x, okay, f minus x is cos minus x, okay, now that is equal to cos x, okay, that is equal to cos x, and that is equal to how much? That is equal to cos x, and that is equal to fx, isn't it? So we saw that if f minus x, the function actually absorbs the minus sign, okay, the function actually absorbs the minus sign, then it is an even function. But if the function is throwing out the minus sign, then it is an odd function. Now quickly I want to talk about types of functions. Okay, you must have heard about into function and onto function. Now what is an into function and onto function? Very simply I want to tell this. Okay, in into function, the codomain is not completely used up. Okay, so that is an into function, means so the codomain is not completely used up, so the range and codomain is not the same. Okay, in onto function, the range and codomain is the same set, because okay, let me erase it. So this is an onto function where the codomain is completely used up by the domain. There is nothing left here. Here there are 2 points left. So that is an into function. This is an onto function, very simply. Okay, you can say this is a many one, this is also many one into, this is many one onto. Okay. So these were few of the types of functions and the special types of functions, because lots of questions come from odd functions, even functions. Modulus function and signum function is their favorite in types of functions. Okay, so that is why I made a special video of this. See to it that you are understanding that. I'll come up with the sums of this also very soon. Okay, more in trigonometry is going to come up very soon. So stay hooked to the channel, and if you have liked the video, do not forget to like, share and subscribe. Also leave a comment for me. I enjoy reading your comments. Thanks all of you. Bye then.